All right, last part of lesson 8.2. So we're now talking about angle of depression, and this is just quite similar to the angle of elevation. Trickiest part is just being able to draw your triangle. You use the same trigonometry to solve it. So angle of depression this time is as if you were at the top of the triangle. So notice the lifeguard sitting up there at the top of the triangle. His angle of depression would be, if he were looking straight out into the horizon, it would be the angle that he has to look down, depression, to get to the object, to get to that swimmer right there. Now notice that angle of depression right there, that is outside of our triangle. Okay, it's not right there. However, if you were to draw a triangle like this, you could either put it there. Most people actually just remember that if you've got parallel lines, okay, so your site right here is going to be parallel with this line right here, then your alternate interior angles are congruent. So this angle right there is the exact same angle as the one on the bottom. So it's the same as the angle of elevation if the swimmer were to be looking up at the lifeguard. So just make sure, do not draw it right here. Just make sure this angle, if you want to draw the triangle like that, just make sure that that angle of depression goes to the bottom too. So a fire is spotted from the top of a 125-foot tall fire tower. If the angle of depression to the fire is 19 degrees, how far is the fire from the base of the tower? Okay, so here's our fire. Look, it's even red. Here's our tower over here. So we're looking down here. There's a nice, lovely triangle. That's a right triangle. So the tower here is 125 feet. The angle of depression to the fire is 19 degrees. Now, remember, angle of depression would be if the guy at the top of the tower is looking straight off and then down to the fire. So make sure if you draw your triangle like I do, that 19 degrees goes in the bottom for the bottom angle. All right, now we're just going to go ahead and label our triangle, call that one theta. So if we go across from our theta, the side is our opposite. Across from our right angle is our hypotenuse, and that leaves the other side to be the adjacent. Now we can just go through, they're wanting to know how far is the fire from the base of the tower. So they're wanting to know how far is this fire. Basically, they're asking for the adjacent side. So we've got to remember, which trig ratio uses the opposite and the adjacent? Oh, where's there enough room to write? Let's just write it over here. So, TOA. All right, so A and O, that's going to give us the tangent. Okay, so we can say that the tangent of our angle, which is 19 degrees, is equal to the opposite, which is 125, divided by our adjacent, which is x. And remember, to get x by itself, we can just flip these places. X is equal to 125 divided by the tangent of 19. And I forgot my calculator. Here it is. Grab your calculator and just plug this in. 125 divided by the tangent of 19 gives me 363.0 feet away from our tower. Okay, all right, let's try another one. An airplane is flying at an altitude of 8,900 feet over water. Okay, so here's our airplane up in the sky, and we know that it's 8,900 feet above the water right here. Here's our water. It spots a raft. Here's our raft. How do we draw a raft? Okay, so it spots a raft right here in the water. The pilots are at 28 degree angle of depression. So make sure you remember that 28 degrees is really the same as the angle of elevation. If somebody on the raft were spotting the airplane right there. What is the horizontal distance from the airplane to the raft? So when they ask horizontal distance, that's kind of a trick because the distance from the airplane to the raft is going to be our hypotenuse right there. But when they ask the horizontal distance, what they really are wanting is that bottom length. So we'll mark it. If you were to do a problem like this on the quiz, I would give you full points if you still solve for the x as long as it was set up correctly. So sometimes they're a little bit ambiguous as to what they're asking for. All right, let's go ahead and label. Here's my theta, that 28 degree angle. So here, this side is opposite. This side's my hypotenuse. and they're asking us to find the adjacent. Okay, so they're wanting the adjacent, they gave us the opposite. Oh, look, it's another tangent that we're going to use. So we're going to say that the tangent of our angle, which was 28 degrees, is equal to the opposite. So 900 over our adjacent, which is x. This is the exact same problem. Wonder why I did two of these. Switch on places, x is equal to 8,900 divided by the tangent of 28. And our calculator can tell us that 8,900 divided by the tangent of 28 is equal to, am I going to write this big number? 16738.5. Okay, so it is quite a ways horizontally from where that airplane is. Somebody has really good eyesight or binoculars, perhaps. All right, Max is sitting in the stands at the baseball stadium. He catches a foul ball and decides to throw it back to a player standing on first base. I'm not even going to attempt to draw this. We're going to say, here's Max, there's the player on first base, and write our triangle. Okay, you could even write first base and Max if you have to remind yourself. If the horizontal distance from Max to the player is 61, again, we're going to call that 61 down there. And the ball travels 76 feet. So the ball went from Max to the first baseman. So this is our 76 feet. What is the angle of depression? Now remember, angle of depression was from if Max was staring straight out here down to that first baseman. But we're going to put that angle in our triangle. Just make it the angle of elevation from the first baseman to Max right there. All right, so when we go through to label our triangle, here's my opposite, here's my hypotenuse, that leaves this lovely side as the adjacent. So we're trying to find, or we know the hypotenuse and the adjacent, so we're trying to figure out which trig ratio to use. Well, our cosine right there uses the ratio of those two sides, so we can say that the cosine of the angle theta is equal to, A is first, so we're going to put the 61 first over the hypotenuse, which is 76. And remember again in your calculator, all you're going to do to tell it to work backwards is hit the second cosine, 61 divided by 76. Hit enter, and it gives you a 36.6 degree angle. And we're finished with the examples there.